Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you all are watching my channel Chemistry Solutions. So today in this lesson, we are going to learn about the preparation of salts. So a salt is a compound that is formed when the hydrogen atom is in an acid is replaced by a metal or an ammonium ion. So then salts can be formed. So look at the syllabus part where we can see about the preparation of salt. So what kind of preparation of salt we can observe in preparation of salt? What are the points are there? You have to describe the preparation, separation and purification of soluble salts by reaction of an acid. So an alkali by titration, excess metal method, excess insoluble base, excess insoluble soluble carbonate will react with acid. So acid can react in titration process. This one will be our second method, B. Method B. Method 1 preparation will be with the excess metal, excess insoluble base, excess insoluble carbonate. So these all are in solid state. So solid, one will be solid, another will be the aqueous, that will be the acid reaction, and soluble salt will be prepared. So describe the general solubility rules. So you all must know the word span. All sodium, potassium, ammonium and nitrate salts are soluble. All sodium, potassium, ammonium and nitrate salts are soluble. Wherever you find these symbols, these elements, all of those salts are soluble. So sodium, potassium, ammonium salts are soluble. Next one is nitrates are soluble. Mhm. Nitrates are soluble, chlorides are soluble except silver sulfate, and soluble except barium, calcium, and lead chloride. Sorry, chlorides are soluble except lead, silver, uh, except lead and silver chloride. Sulfates are like barium sulfate, calcium sulfate, and lead sulfates are insoluble. Carbonates are insoluble except sodium, potassium, and ammonium. Then hydroxides are insoluble except sodium, potassium, ammonium, and calcium. Calcium is partially soluble. So you all have to memorize all of these solubility rules to prepare the salt. You have to identify the salt first. Is it soluble or insoluble? Then you have to move on. So describe preparation of insoluble salt preparation. So this will come under the ionic precipitation method. It will be our method C. Then in that next define hydrated substances, a substance that is chemically combined with water, an anhydrous substance as a substance containing no water. Define the term of crystallization as the water molecule present in hydrated crystal including copper sulfate and water. Always remember one thing here, that if I will give you the understanding of this here. Number one is about the hydrated salt. The salts which have water of crystallization in it, that is called as the hydrated salt. So CuSO4.5H2O is our hydrated salt, and when we will heat it, it will convert it into the white powder, that is the copper sulfate. So in this water is called as the water of crystallization. So this is the water of crystallization which is present in hydrated copper sulfate. The color of hydrated copper sulfate is blue, whereas the color of anhydrous salt, this one is the anhydrous salt, which is in powdered form and it's white in color. Now come towards the cobalt chloride, CoCl2. If it is hydrated, its color is pink. When the water will be evaporated from it after heating, it convert into blue powder. So these are the blue crystals. Hydrated salt are the crystals, and cobalt chloride forms pink crystals. Crystals will break when water will evaporate. So this is what they are saying about the term water of crystallization which are present in hydrated salt. So you people will come to know anhydrous without water and hydrated the compound with water. This is the one which we have discussed up till now. Now move on towards our preparation of salts. There are three methods which you all have to know. So now I am moving on towards the method 1. Method A, adding acid to a solid metal insoluble base or insoluble carbonate. So bases are the metal oxides and metal hydroxides. You now all can pause the video and note down and memorize and go through all of these steps and memorize it accordingly, right? So here are the crystallization process as well. Crystallization process will start when you start heating the heat the solution. From here you can start the crystallization process. Heat the solution to evaporate water, make the solution saturated, then leave the filtrate in a warm place and remove the heat before that and dry and crystallize. Decant excess solution and allow crystals to dry or blot to dry with filter paper. So this is the method which you have to memorize, note down the steps and get it into the visualize process. So the question can be asked to all of you by giving you these kind of images. They can ask what all of the purposes of step 1, 2 and they can ask the apparatuses. But if you have to do this type of questions in your planning questions, then do not forget to draw the diagrams, label diagrams. Even they are not asked to you to draw the structure, draw the diagram. You have to draw the diagrams in a planning questions and label the diagrams. So this one is basically the spoon spatula, and this one is the stirrer to make it even. Why we are going to heat this mixture? To mix the solution, to increase the rate of reaction and to mix the solution well. First, cobalt 2 oxide. This one is the solid thing is going to be this one, the solid part, and this one is the aqueous part, and we are going to get our aqueous cobalt 2 sulfate salt. So now come towards first part. We are going to mix the solid into the liquid, then we are going to heat it and stir it. We are providing heat to increase the rate of reaction, then we will get this unreacted solid here. So this is the preparation of salt. In the next step, we have to filter the solution. After filtering, remove the excess uh, cobalt 2 oxide. Excess cobalt 2 oxide should be removed. You have to react all of the acid with the excess cobalt 2 oxide. If you are not going to react all of the acid and you are not going to wait all of the acid should be reacted, then your salt will be contaminated with the presence of acid, and it will be the acidic salt. So some exam type questions: what is the name given to the unreacted material in this salt preparation? This is a question from taken from the past paper. So what is the name given to the unreacted material? That unreacted material is basically the excess. So this is the substance which basically remaining after filtration on the filter paper. It is called as the excess. And in the conical flask, I cannot draw it well here. We will get our copper 2 sulfate. So the word saturated means no more solute can be dissolved in a solvent at a constant temperature. Method C is ionic precipitation. Follow these steps to prepare insoluble salts. So aqueous, here two aqueous salt solutions, and it will react together. We are stirring it, mixing all of these two salts together. After that precipitates, the solid part will be formed. Then we will filter the salt. Our required part is residue of solid, that is barium sulfate. So barium sulfate will be separated at the top as a residue on the filter paper. So this filter paper should be washed with distilled water and dry in folds of filter paper. So here are the steps. You can note it down how to prepare an insoluble salt by the precipitation method. There are some exam style questions. How can you distinguish between chlorine and sodium chloride? Answer add litmus paper, it will bleach with chlorine, but nothing happens to it with sodium chloride, because sodium chloride is salt with the neutral pH. That is the neutral part, so it is not going to be talked about like this. So copper carbonate is basically the green color compound. Copper oxide is black. When we will heat copper carbonate, it turns into copper oxide. For hydrated salt, heat to constant mass and ensure that all the water has been evaporated. Same in the case when we are decomposing a compound, calcium carbonate, by heating it, we have to heat it strongly that all the water should be evaporated. For strong heating, the apparatus which we can use, that is called as the crucible, is preferred because it is a better thermal conductor. So that's why we can use it. So here is the method B, reacting dilute acid and alkali soluble base. This is basically the titration method. You all can pause the video and read all the points to prepare a soluble salt by using two soluble, one soluble acid, one aqueous, and two soluble solutions, one solution, two soluble. All are aqueous in state in these states. Your alkali is aqueous, your acid is aqueous, and finally the salt which we are preparing are aqueous. So all the things, all the reagents and the product are aqueous. So what basically titration apparatus look like? This one is the burette, dilute sulfuric acid. What we have to do, there are some important points. So this one is the white tile is used to form to observe the clear change in the indicator. The indicator which are the part of your syllabus are thermophthalin blue and methyl orange. This one is the burette, dilute sulfuric acid is in it. When you will uh, clean this, wash this burette, wash it first with water and then pass the acid from it and level it to the this level should be open. You have to open till then. Here the acid uh, should be here till this point. You have to open it and you have to put it. This point should be covered, which is present over on this at this tip of the burette. So it should be open first, and then you have to start the process. Titration important points are color change of indicator, color of the solution in the conical flask after titration, and point depends upon the solution present in the burette. Example given, if the acidified potassium magnate 7 is in the burette, then the end point will be purple, meaning burette end point will depends upon the liquid present in the burette. Color will be shown which is present in the burette. If in the burette potassium magnate is there, after the experiment, the end point will be purple in the conical flask. If the burette is filled with the acid, an indicator is methyl orange, and if methyl orange is there, right, in the conical flask, then in that case, the end point acid, the color of acid will be given. That is the that will be the red. Use the word volumetric pipette instead of simple pipette. Remember, do not use simple pipette, use the volumetric pipette, word volumetric pipette. Titration important points, further important points are you can speed up the process during the drying the process. If you are speed up the drying the process, what is the drying the process? If you are drying the crystals, for that you have to use the fan by increasing the temperature or by using a hair dryer if you have one, not a catalyst. Catalyst is not used to dry the crystals. The meaning, what does it mean concordant values? Concordant values are basically differ by only zero point 0.1 and zero point 0.2. Select the best titration results and calculate the average volume. Average volume will be calculated by the nearest values, that are the concordant values. While preparing the solution in the volumetric flask after adding water, it is shaken to make sure that the concentration of the solution is even. So that's why you are making it. Some more important points for the titration point of view. The universal indicator is not used in titration since it doesn't have a clear endpoint. So we cannot use universal indicator. Adding water in a solution changes the concentration, but moles remain same. By adding water, concentration, it affects on the concentration, but number of moles will remain same. Taking a small volume out of a large container. One important apparatus is in the preparation solution is the volumetric flask. This one is the volumetric flask. It is marked, for example, 1000 ml or 250 ml. If in the volumetric flask you will have taken out the 25 centimeter cube out of 1000 centimeter cube, then in that case small volume out a large container changes the moles. If he takes 25 centimeter cube out of 250, then the moles are less in 25 centimeter cube, but concentration in both of the container. Rinsing of apparatus is associated. Burette and pipette will be rinsed with the solution, since rinsing with water will dilute the solution. If we are using the water, burette and pipette will be rinsed with the solution, meaning the solution which you are taking in. For example, you are taking acid in burette, you have to wash burette with acid. If you are taking alkali in pipette, you have to wash the alkali with pipette. First pass the alkali with the fill it first with alkali and then pass it out. Since rinsing with water will dilute the solution, so water will dilute the solution and our results will be affected by doing this. Whereas conical flask should be rinsed with the water, because conical flask should be rinsed with water because dilution doesn't affect the number of moles of solution in the flask. So it doesn't affect on the flask whatever the water is there. So white tile is used to enable the color change to be observed more accurately. Now we are going to do a question related to the titration. A student transfers 4.0 centimeter cube aqueous potassium magnate from the burette into the apparatus. The endpoint will be R purple because we have aqueous potassium magnate, yes, in the burette. Name apparatus A, this one is our conical flask, so we can write conical flask here. Name a suitable apparatus to measure exact 25 centimeter cube. It can be measuring cylinder if you are want to measure exactly, you can measure. The student heats the mixture in apparatus A until it reaches 60 degrees centigrade. Name a suitable piece of apparatus to measure the temperature, that is thermometer. Now we are moving towards exam style questions. How can you make crystals? Answer is heat it till take the filtrate and heat it till the point of crystallization. Leave to cool gradually. Filter, dry, and collect the crystals. How can you detect the point of crystallization? Place a stirring rod. Place a stirring rod in the solution and see the formation of the first crystal on it. So what you have to do, in the saturated solution, you have to put the glass rod in the solution. After some time, you can see the crystals are forming on the glass rod. So remove the heat and then allow the crystals to cool down, filter the crystals and then cool the crystal, wash the crystal and then dry it. How can you distinguish between copper sulfate salt and copper carbonate salt? So acidify with hydrochloric acid and add barium chloride. There will be white precipitate with sulfate but no white precipitate with carbonate. Or you can simply say that just add hydrochloric acid in which nothing happens with sulfate but a fizz or effervescence of carbon dioxide will occur with carbonate. Always remember when gases are produced. So in the observation you have to write effervescence or fizzes. How can you distinguish between sulfuric acid and sodium sulfate? This is the salt and this one is the acid. There are three tests you can use. A metal carbonate in which carbon dioxide will be produced with sulfuric acid, but there will be no change with sodium sulfate. You can add a metal in which hydrogen is produced with sulfuric acid, but no change in sodium sulfate. Finally, you could use an indicator like litmus paper. It will change to red with sulfuric acid, but there will be no change with sodium sulfate. So this is all about our today's lecture, that is about the preparation of salts and you people have learned so many things. All the bullet points we have covered, that is related to your Cambridge syllabus. So I hope so that all of you have learned it well. So signing off, Miss Aisha Manzoor.